Assalamualaikum and good day to everyone. In this video, me and my group members will present our topic that we have chosen for group project assignment, which is metabolic syndrome. Alright, my name is Muhammad HASSANUDIN bin KHALID and I will be presenting first. So, what is metabolic syndrome? It is a condition that increases the risk of heart disease. Among of its symptoms include abdominal obesity, high blood pressure, and high blood sugar level, and so on. But in this presentation, we will focus on low HDL. HDL here means high density lipoprotein. So what is HDL? It is a good cholesterol that supports the cardiovascular health by transporting the good cholesterol from the arteries to the liver for excretion and reduce the risk of heart attack and stroke. So with that being known, we will find out about the relationship between HDL and how it affects the body mass index. Next is the objective of study. First is to describe the descriptive statistic of high density lipoprotein and body mass index BMI. So high density lipoprotein here will be the independent variable, which means it can be changed, while the BMI will be dependent variable, which means that it cannot be changed because it will be the effect of what we will see from the independent variable. So the second one is to identify the strength and correlation between high density lipoprotein and body mass index. The third is to model the HDL and body mass index using simple linear regression. And lastly is to make prediction using simple linear regression model. Next is the significance of study. So studying the relationship between HDL and BMI is important because it helps to identify how body weight and fat distribution impact the health of the heart. And understanding this relationship can create plans to increase the HDL levels and manage the BMI, thus reducing the risk of cardiovascular disease and metabolic disorder. Other than that, insight from this study can inform public health policies and personalized treatment plans and give healthier lifestyle recommendation. Ultimately, this will enhance the overall health outcomes and preventing chronic disease for everyone. Next is the methodology of the study. First is data description. So types of variable used here is the quantitative discrete variable. This is because the data is measured on numerical scale and it is countable and takes integer value. There are no intermediate value possible between those numbers within the context of the data set. For example, the number of people with a specific BMI, it cannot be 2.5 people, 3.5 people. It has to be a whole number. And next is the level of measurement. The level of measurement using ratio. Ratio is used for quantitative variable, and this means that the observation of the variables can be arranged and ranked. For example, people with the HDL levels of 40 has less HDL than people with HDL level of 50 and 60. Next is graphical technique. The graphical technique we use here is scatter plot. It is a visual way to describe the relationship between the variables, which is HDL and BMI, and it uses dots to represent the value. Okay, so the graph will illustrate the relationship between the HDL level and BMI, and it will show little to no linear correlation between them. And as indicated by the scattered blue diamonds point and the flat orange line you can see at this picture here. So other than that, the normal probability plot reveals that while BMI values are roughly normally distributed, deviations at higher BMI levels suggest skewness or heavy tails, which means HDL is not a strong predictor of BMI, and the BMI data show some non-normal characteristics, particularly at higher values. Alright, so that's all from me. Move on to IMRAN.
For the descriptive statistic analysis, the minimum value of HDL or X, and BMI Y are calculated using the formula for finding the mean, which is the sum of the terms divided by the number of terms. For HDL, the minimum value is 48.63, while for BMI it is 27.19. These figures denote the lowest observed level of HDL and BMI, respectively, within the dataset. For the description, in the determining the median value of HDL and BMI, the position of the middle terms within each dataset is calculated using the formula n plus 1 divided by 2. For HDL, which dataset size of 30, the middle terms position is at the 50.5 position. Therefore, the median is calculated as the average of the 50 and 60 value, resulting in the median HDL of 47.5. Similarly, for BMI, the median is found to be 26.3, compute as the average of the 26 and 27 value in the dataset. This figure represents the central tendency of the HDL and BMI distribution, providing insight into typical value within into dataset. To identify the minimum and maximum value within the dataset, the minimum and maximum functions are applied. For HDL, the minimum value is found to be 28, while for BMI it is 16.6. This figure represents the lowest observed level of HDL and BMI, respectively, within the dataset. The maximum HDL value is 85, indicating the highest observed HDL levels, whereas for BMI it is 45.4. The maximum BMI value is recorded. This insight provides essential information regarding the range of value present in the HDL and BMI dataset, in understanding their variability and potential outliers. To compute the standard deviation, the formula for variance is applied, followed by taking the square root. For HDL, the variance is calculated as 13.619, while for BMI it is 6.50. This value represents the measure of dispersion within the HDL and BMI dataset, indicating the average deviation of individual data points from the mean. A higher standard deviation suggests greater variability in the data, while a lower standard deviation implies more consistency. This insight into the spread of HDL and BMI value provide valuable context for understanding and distributing and variability for this variable which is within the dataset. The Pearson correlation coefficient R between HDL and BMI is calculated as 0.1962, indicating a weak positive correlation between the two variables. The coefficient of determination R square power of 2 is determined to be 0.0385, implying that only about 3.85% of the variability in BMI can be explained by the variability in HDL levels. Additionally, a simple linear regression model is constructed by which the equal y equal 31.6439 minus 0.0915x, where y represent BMI and x represent HDL. This model suggests that for every unit increase in HDL, BMI is expected to decrease by 0.0915 units. This statistical analysis provides insight into the relationship between HDL and BMI in understanding their association and predictive capability within the dataset.
Assalamualaikum warahmatullahi wabarakatuh. My name is AMIR FAUZI. My metric number 2023 seat 80148. Presentation. We can see the graph of the axis X is a BMI, then is a HDL, while the axis for Y is a BMI. So we can see that problem, the graph is a plot for the increase always increase. So that explain about the relationship between BMI and HDL is positive, always positive. Okay, for the descriptive statistic, we can see sample size. We choose 30 for the axis of X and axis of Y. Then the mean of axis X, which is BMI, is 48.3333. Then for the DHL, 27.193. This mean is plus for all the data. Then divide from the sample size, which is all data, 30 data, we plus, then divide for 30. Then median is 47.5 for BMI, then 26.3, which is median. We need to arrange or sort from level from the smaller number to the bigger number. Then we okay, for the median, this is a center lah, so we need to sort. Then we see the middle of the number, so that 50 and 60 place. So we take the data, then divide by 2. So we get for the BMI is 47.5. Then for DHL is 26.3. So minimum is 28. How to search a minimum? We need to sort from the smaller to the bigger. Then the smaller is 28 for BMI, DHL 60.6, maximum is 85, then 45.4. For the standard deviation, 30.18 for BMI. Then the interpret variable, which is DHL is 6.1493. Okay, for the correlation and regression analysis, we can see the graph is increase. So the we can conclude is there are positive relationship between BMI and DHL. Okay, for the correlation, that is a formula is R equation xy, subtract for equation x, multiply equation y, divide n, then divide set equation x power of 2, then substitute equation x power of 2, then divide for the data sample, then multiply equation y power of 2, then equation y power of 2 divide by data. Then so 36214.6 subtract 1460, multiply 816.8 divide 30, divide set 76,000, subtract for the 1460 power of 2, then divide 30, 23 23,281.94. Subtract for the 816.8 power of 2, divide for 30. So we get the answer is 0.1962. That's a formula to solve the regression. So second equation of the regression line, the formula is y a plus bx. So y a we can get from the Excel. So the answer is 31.6436. Then b we also can get from Excel. So the data is negative 0.0915 x. That is for we place any number or sample data. So at the D, example of prediction using the regression equation, we put x for the 30, so that the answer is 28.8986. Okay, for the for question E, discussion of the slope of the regression line and its meaning. So the value of slope B, which is a negative 0.0915. The negative value of B indicating a positive relationship between body mass index, which is a BMI, and higher destination lipoprotein, HDL. This means that for the every 1 unit decrease 1% between the BMI and the HDL. Then the value of R power of 2, the regression model, we take from the question D. We take from the question B, then we power of 2 lah. So the answer is 0.0385. Okay, for the conclusion, the analysis of BMI and HDL data reveal key insight. Discrete statistics show typical value and variable for both of variable. The weak correlation and the simple linear regression model indicated that HDL is not significant predictor of the BMI. Probability plot indicated the BMI distribute derivative from the normal. So the graph show the positive relationship between the HDL and BMI. So BMI is not a reliable indicator of HDL, and future research should consider the normal distribute of BMI within HDL. So at the last slide, we put the reference. We have 3 reference, which is we to know what BMI, what the HDL, then reference from for our formula of a statistic. That's all for me.